Alright, what's going on, everybody? Welcome to another video. So today is actually my first Python video on this channel. Now the reason why I'm doing this video is because I suddenly got the 1 a.m. motivation to teach some people how to program. Today I'm going to teach you guys how to make your very first machine. It's a linear regression model. Now, we're going to use the gradient descent algorithm to train the model. Maybe it sounds like it's big words, but honestly, it's not. It's like super simple stuff. Like, seriously, super simple stuff. On a side note, I'm going to tell you guys that I'm not going to go too in-depth into the explanation of things. Like, I'm not going to tell you why we're using the formulas that we're using, or like why they're better, or why they work. Like, I'm literally just gonna write them and tell you guys that's what you have to write. Okay, so I'm gonna try to keep this as short as possible because it's pretty damn late, and also, like, this is kind of a test video. I just want to see like how it works or something. So anyways, whoops, I'm writing in Arabic. All right, so first thing you want to do is import numpy as np. Then you want to import matplot pyplot as plt. These two are the only libraries that we're going to use for this model, surprisingly. So first thing you want to do is you want to create your x-axis. It's an array, and we're going to put, for this video, I'm going to say 10 values. 6, 7, 8, 9, 10. Okay. And then for the y train is, well, it has to be the same number, so 10 values. I'm going to say like 4, 6, 5, 7, 8, 10, 12, 6, 7, 14, 13, 15. Okay, and now to help you guys visualize this, I'm going to scatter these numbers on a plot. I'm going to set the marker to X and the color to red. So this is my graph, okay? These are the dots, or the points, that I'm going to feed my machine. And the goal of my linear regression machine, it's in the name, is to build a linear function that will be the best fit for all of these points. Okay, so you just picture a line that will go through all of these points. That is the best fit line. Like, it's the best possible line that could exist on this plot, and that's what our linear regression model is going to do. Now you might think, okay, well, why would that ever be useful? Well, let's say that I want to ask my machine, oh, well, based on this data, what would be the output if my x was, for example, 15? Now, as you can see in my data, my x stops at 10. So I wouldn't know what my x would be at 15, or what like it would ideally be. But my machine can know, because it will find the best fit line for this data. You understand? I'll give you examples once we programmed the whole machine. So now that was said, the first thing you need to do is to define a cost function. The cost function takes 4 variables, x, y, w, and b. And I'll explain these as we go along, but you should know that x represents my x train and y represents my y train. Okay? So we're going to define the variable m as being the length of x. And we're going to define cost as initially being 0. And we're going to start a for loop. So for I in range m, do something. Now, just to stop and explain a bit why we did this, well, it's simple. Because we want this for loop to run exactly the same amount of times as I have data here. So basically, I have 10 numbers here. That means I want my for loop to run 10 times. So that's pretty much it. So first we need to define, in this for loop, we need to define what the function for my line is going to be. Now, as everyone knows, the function for a line is wx plus b, right? Super simple. You learned this in high school. But you need to remember that your x represents this whole array, right? The whole reason we're doing a for loop is so that we can actually index our x and our y's. So don't forget to index your x. Then we want our cost to be equal to itself plus fwb minus y indexed squared. Now, as I said at the beginning of the video, I'm not going to explain why we're using this formula. It's just important that you know that we're using this formula, basically. So now that that's done, that you finished the summing up all of the different costs, you want to average them, except it's not really an average. If you wanted to average them, then you would divide the cost by m. But we're doing something special. We're going to divide it by 2m. Okay? Doesn't matter why. That's just why we do it. I'm going to give you a brief explanation of what this cost function is. So basically, imagine a line here, okay? So picture a line that goes right through here like this. The distance from every single point to the line, is the cost, right? So let's say that my line is at 1 unit away from this point here. That would mean that the cost for this point is 1. And I'm summing up all of the costs and then dividing them by 2m. So imagine this is 0.5, this is 1, this is 1, this is 2, blah, blah, blah. I'm summing all of these costs up, stacking them in this variable, and then I'm dividing it by 2m. And this is done because I want to know how accurate my machine is. The lower the cost, the smaller the cost, the closer it is to 0, the more accurate my line will be. Okay? So now we want to return the cost. And that's it for the first function. Super easy stuff. Now you want a gradient function. This also takes 4 parameters. The x, dy, dw, and dp. Same thing as before, you want to define n as being the length of x. And now we're going to do something that's a tiny bit more complicated, but it's super easy. We want the dw and the db. Now technically this should be dj over db. It's over dw. It's the derivative of the job function with respect to w, and this is the derivative of the job function with respect to b. Okay, but I'm just going to write dw and db for short. So we're going to start a for loop. And we're going to define our function yet again. Don't forget to index your x. And now we want to do something with our dw. So the derivative of the job function with respect to j is fwb minus y indexed. Sorry, this is fwb minus y indexed times x indexed. Okay, this is just the derivative of my job function with respect to w. Okay, now because I have to do the sum of all of it, I'm just gonna add a plus sign here. That's because I'm summing up all of the values for this derivative, and I'm gonna do the same thing for db. It's fwb minus y indexed, but this time we're not gonna include this x indexed because it's with respect to b and not with respect to w. I'm not going to go more in depth than that. You don't need to know calculus to do this program, this machine. Just for general knowledge. So after we're done with the for loop, we want dw to get divided by m, and we want db to also be divided by m. And then we're going to return dw and db. And that's it for our second function. Now we want to define the descent algorithm. Okay, this is going to take an x value, a y value, an initial w value, an initial b value. It's going to take an alpha, it's going to take a iteration, and it's going to take my cost function, and it's going to take my gradient function. Okay, So yeah, it takes a lot of parameters, but they're all super easy once you like get to know them. The x and the y, you already know what that is. That's the two arrays we have here. The w initial and the b initial, it's the same thing as w and b. You know, it's just that whatever they start with, it doesn't matter, but they're just w and b. Alpha is, well, you'll see later. Alpha, iteration, cost. Cost is just the cost function. Gradient is just the gradient function. These two, you'll see. No, sorry. These two, you'll see what they are in literally just a second. So the first thing you want to do is you want to define w as being the initial w and b as being the b initial. And then you want to say for I in range iteration. So now you know what iteration is. Iteration is literally just for this. It tells us how many times you want to run the for loop. You're going to decide. So for I in range iterations, now we want to grab our derivatives. So we call our gradient function and we pass on the arguments. And then you want to modify w as being minus equal alpha times dw and b alpha db. And then finally you want to return w and b. Okay? So now when you look at this program, would you be surprised if I told you that this is it? I think you'd be surprised. Because there's no way that, wow, my first machine is that easy. It is. It really is that easy. And I'll even show you that is that easy. WB is equal to descent function x train, y train. I'm just passing the variables. 0, 0. Now 0, 0 is going to represent our initial w and initial b. You could put any value here. It doesn't matter. I'm just going to put 0, 0 for simplicity. My alpha, I'm going to put 0, 0, 1. My iteration, 100,000. 100,000, cost function, and then gradient function. Okay? And then I want to print WB. So now I'm going to run my code. This is the W that I get, and this is the B that I get. For now, these values don't mean anything to you. But I'm going to show you why they're actually super important. They're important because I'm going to actually plot them. Now, before I plot them, I need to define a plotter function, which is going to take the x, the w, and the b, and it's going to return, it's going to return w times x plus b. That's it. Now I want to plot, so plt.plot x train plotter x wb, or x train, sorry, wb, and I want to set the color to blue, but this is completely optional. Okay, so now once I click run, guess what? I'm going to see my function, and this function that my machine came up with uses this as a w value and this as a b value. Okay, so pretty much that's pretty much it. This is the best fit line for this function. Now, if you want to double check the accuracy of your model, what you need to do is simply to print out the result of the cost function. So you want to print cost function x train, x train, y train, w, and b. Now remember, the smaller the cost, the more accurate it is. 0.34 is relatively small. Now I don't know if we can make it even more precise. No, we can't. You see, I changed alpha, I made it bigger. I think if I make it smaller, it's going to be the same thing too. Yeah, 0.34. So sometimes you might get a value for your cost function, and if you play around with the alpha, then you'll see that this cost function value will change. Now you can play around just to be sure. Like as you can see, I changed it a couple of times, just to see if it would affect my cost function. It didn't, so that means that I already have my best cost function. Like this 0. Well, I guess this 0.3381 whatever is the most accurate line I'm going to get for this function or for this data set. So now you may ask yourself, okay, well, I mean, I don't really understand what I did. I just gave this machine a bunch of points and it came up with the line that is the best fit. So what? Well, I'll tell you so what. Now you can actually define a predictor. So the predictor function, and it's going to take an x, a w, and a b. Who would know? And it's going to return a w times x plus b. Now, I know we could have just used this plotter, but I wanted to like put it separate. Okay? So now you can prompt the user, say like, I don't know, desired input is equal to integer that input, enter your desired number, and then you're going to print the outcome. So you're going to print output, or I guess predicted output for this number is predictor. My God, how did I write this? Predictor is a predictor desired input W and B. Okay, so this should be good. So now my desired number, I want to predict what 20 will be. So now the machine took my 20 and it predicted that the y value for this 20 will be 27.85. Now, I'm not sure why my plot didn't, plot. So I'm just going to like copy this and delete it and see if that makes sense. So if I kept this line going all the way until x equals 20, would I get around 28? It makes sense. It makes sense because at 10, I was around 14. So at 20, I'd probably be around 28. All right. So, okay. Well, that's pretty much it. You've figured out how to make your own machine using a using a gradient descent algorithm. So, okay. Well, I hope you guys are proud of yourselves. I hope that this code was at least somewhat clear to you. I know I didn't go too much into details, but I think this is better. I think it's better like this, especially for like a first ever Python video. I've never recorded myself coding before on Python. So yeah. And just a side note, this is how I started machine learning. My first ever machine was a linear regression model. So yeah, I hope you guys found this video interesting. I hope hope you guys will come back for the next one. Let me know if you have any questions, any concerns. Let me know if my video was absolute garbage or if it was, nice to watch. All right, appreciate you guys for being here. Appreciate you guys for watching the video. Have a good night, good day, good evening, good morning. Have a good rest of your existence.